Alright, in this video we're going to talk about factoring by grouping. Right? It's one of the methods that we have for factoring an expression. So in the grouping method, what we do is we split the expression into groups, and those groups have to have the same number of terms, so like 2 terms in each group or 3 terms in each group or whatever it is. So we split the expression into groups, and then we factor out a common factor from each group. Right? So I did a video about factoring out common factors, so if you haven't seen that yet, check that one out so you understand what we're doing here. We use that method as part of the factor by grouping method that we're going to do here. And the biggest clue, one of the hardest things when you're learning how to factor is knowing which method to use in which situation. Factor by grouping is usually pretty easy to identify. When you have 4 terms, pretty much you're going to use the factor by grouping method and not any of the other methods that we have. And I'll have videos for all the other methods that we use, so you can check those out as well. But 4 terms is going to be factored by grouping. 6 terms, 8 terms, you usually don't see stuff like that. But if you have a big polynomial expression with an even number of terms, generally the factor by grouping method is going to be probably the only method that you're able to use other than the common factor method in order to try to factor it. All right, so pretty easy to identify when to use factor by grouping. When you have 4 terms, like in these couple examples that we have up here, this is the method you're going to use. Right? So the first polynomial we have x to the third minus 3x squared minus 5x plus 15. Right? So there's 4 terms there, which tells me I'm going to use factor by grouping here. The first thing I always want to do, though, no matter what method I'm going to use to factor, I always want to look for a common factor first. Right? So look at the 4 terms we have here. X to the third minus 3x squared minus 5x plus 15. Do all 4 of those terms have any common factors? And the answer in this case is no, they don't. Right? A couple of them do, like the 5 and the 15 have a common factor of 5. The 3 and the 15 have a common factor of 3. Right? The first 3 terms have a common factor of x. But there's no common factor shared by all 4 of those terms. And in order to use the common factor method of factoring, that common factor has to be in every single one of the terms that you have, right? So we don't have that here, so we can't use the common factor method. So since we have 4 terms, we're going to do factor by grouping. All right, so what I do is I split my expression into groups, and usually the easiest way is just, let me take my first couple terms here and my second couple of terms, and those will be my 2 groups, right? Each group has 2 terms in it. All right, now, I put those parentheses around there, not that that's the factoring, like that's not the finished product here, just to separate my 2 groups. So my first group is the x to the third minus 3x squared. My second group is going to be the minus 5x plus 15. Right? So once I split my expression into groups, I look for the common factor for each individual group. Right? So now I'm just looking at this first group, the x to the third minus 3x squared, and I want to pull out the common factor from that group. Well, they don't have any number as their common factor, right? Because this is just a 1x to the third power, but they both have x's in them. And they both have at least an x raised to the second power. Right? So if you watch the video I did with the common factor, I said there that when you have variables raised to powers, your common factor is going to be that variable raised to the lowest power that you have, which in this case is that second power. Right? So my common factor for that first group is going to be the x squared. Right? And then I need to fill in this parentheses is what's left behind when I factor out that x squared. Well, when I take x squared away from x to the third, right? I have 3 x's there. I'm taking 2 of them away, which leaves me with 1x, so I just have an x here. And then that minus 3x squared, well, when I pull out that x squared, all that's left is the 3. Right? So I have x squared times x minus 3. That's factoring out the common factor from that first group. Right? And remember, when you do that common factor, if you want to double check it, just use the distributive property. X squared times x gives me x to the third. X squared times minus 3 is minus 3x squared. It all checks out. All right, my next group now I do the similar thing for that second group. So I have minus 5x plus 15. So now I look for a common factor in the negative 5x and the plus 15. And here, only one of them has the variable x. So my common factor is not going to involve the x. But they both have a number, right, a negative 5 and a 15. And those 2 have a common factor of 5. Right, so I pull out that common factor of 5, and if I pull out that factor of 5, what would I have left? Well, I would have a negative x here, and then a plus 3. Right, so the negative 5x, if I pull the 5 out, what's left behind is the negative x. If I divide the 5 away from the 15, what's left is a 3. And again, if you'd use the distributive property, 5 times negative x is negative 5x, 5 times 3 is 15. It checks out. All right, now, here's the key thing for the factor by grouping method. After you split it into groups and you take the common factor out of each group, the two parentheses that you have left behind have to be exactly the same thing. Right? Are our two parentheses there exactly the same thing? They're not. Right? This one has a positive x and a minus 3. This one has a negative x and a plus 3. So they have the same terms there, but the signs are switched around. Right? Now, in this case, there's something we can do here to make them be the same. Right? Since they have the same numbers and variables, just all of the signs are different, instead of factoring out a positive 5 here, if I factor out a negative 5, well, that would make this then a positive x, and it would make this one a negative 3. Right? If I pull that negative out with the 5, it changes the signs of what was left behind. Right? If I do negative 5 times x, that's negative 5x. If I do negative 5 times negative 3, that's positive 15. And now these two parentheses are both exactly the same. They're both in x minus 3. Right? In order to proceed to the next step in the factor by grouping method, those two parentheses have to match exactly. And if they don't match, you can try that trick of pulling out the negative, and that might make it work. If that still doesn't help, then you cannot factor it by grouping. Right? Remember, not every single expression that you see can be factored. There are plenty of expressions out there that you cannot factor at all. Right? So sometimes you try this method and it just won't work. Right? But in this case, it will work because we have our two parentheses there match up. Right, so now here's really the last step of doing the factor by grouping method. What we've got now is two terms. Right? We have an x squared times an x minus 3, and we have a minus 5 times an x minus 3. Those two terms have a common factor, which is the x minus 3. Right? This is an x squared times x minus 3. This is a minus 5 times an x minus 3. So now what I can do is I can pull out that common factor from my two terms that are left. The x minus 3 is that common factor that I can pull out. And when I pull out that x minus 3, what's left behind is the x squared and the minus 5. Right? And there's my factoring. Remember, factoring is taking an expression that involves addition and subtraction and rewriting it as a multiplication expression. And that's exactly what I have here. I took this x to the third minus 3x squared minus 5x plus 15, and now it's written as multiplication, x minus 3 times x squared minus 5. All right, so we have factored this. All right, so that's the factor by grouping method. So again, to identify when to use this method, generally it's when you have 4 terms or 6 or 8. You have to have an even number of terms because your two groups have to have the same number of terms in them. Right, so if you have 3 terms, you can't use factor by grouping. If you have 5 terms, you can't use it. It has to be an even number of terms. Usually it's 4, but it would also work with 6 or 8 or 10. All right, so we identify that. We split our expression into two groups of equal size. Right, both groups have 2 terms. We take the common factor out of each one of those individual groups, making sure that when we do that, the parentheses that we have left behind match. And then basically, once you have that, once those two parentheses match, those parentheses make up one of your factors, and the stuff that you pulled out, the x squared and the minus 5, makes up your other factor. All right. And then if you want to double check to make sure you did this correctly, well, just multiply it back together, right? Use the FOIL method here, right? X times x squared gives me that x to the third power. X times the minus 5 gives me the minus 5x that I started with. The minus 3 times the x squared gives me that minus 3x squared. And the minus 3 times the minus 5 gives me that plus 15. It all checks out. I know that I factor this correctly. All right, so that is factoring by grouping. All right, so let's look real quick at another example here of factoring by grouping. All right, so once again, I identified to use this method because I have 4 terms here. All right, so let me take my first group is that 2x to the third minus 4x. My second group will be that minus 3x minus 6. Right, and keep in mind, when you have the negatives there, those negatives have to be included with whatever number comes after it or whatever term comes after it. Right, so here that negative went with that 5x. Here this minus goes with that 3x when we split apart our groups. All right, so my first group, 2x to the third minus 4x squared. Well, the 2 and the 4 have a common factor of 2, and the x to the third and the x squared have a common factor of x squared. Right? Remember, with the variables raised to a power, it's the one raised to the lowest power. That's what your common factor is. Right? And if I pull out a 2x squared, what's left behind? Well, I pulled out the 2. I pulled out 2 of the x's, so I have 1x left behind. Here, for the 4x squared, I pulled out the x squared, and when I did that 4 divided by the 2, I'm going to be left with a minus 2. All right? And again, if you want to double check, multiply this back in, distribute it to double check. 2x squared times x is 2x to the third. 2x squared times minus 2 is minus 4x squared. All right? So that's my first term and the common factor. Now for the next one, I have a minus 3x and a minus 6. All right, so I have an x and then no variable, so I don't pull an x out here, but the 3 and the 6 both have a common factor of 3, which if I pull out just the 3 itself, it would leave me with a negative x minus 2. All right, so 3 times negative x would be negative 3x. 3 times negative 2 would be negative 6. Now, my two parentheses here do not exactly match, right? One is a positive x minus 2. The other one is a negative x minus 2. Right, so I cannot proceed to that next step like we did up here because my parentheses do not match. Right, so can I do like what I did last time to make them match? Well, what if I pull out a negative 3 instead of just the 3? That would make that a positive x and then a plus 2. And guess what? My parentheses still don't match. Now I have an x minus 2 and an x plus 2. All right, does that mean that we did something wrong? Not necessarily, right? Remember, not every single expression can be factored, and when an expression cannot be factored, it's prime, right? Just like a prime number is a number that you cannot factor any further, like 5 is a prime number because it's only 1 times 5. There's no other numbers that multiply to 5. Well, algebraic expressions can also be prime if you cannot break them down into two things multiplied together, right? So in this case, this is prime. Now, if you see one like this, I would encourage you to just double check to make sure you did those first couple steps correctly. Make sure you didn't miss a negative sign somewhere because you don't see a lot of these that are prime, but every once in a while when you're doing like a homework section or maybe your teacher gives you a quiz or a test, they might throw one in here that's prime just to make sure you really know what you're doing. But if you're doing like a homework or a quiz or a test and like you're finding that every single one is prime, probably you're making mistakes, right? So I would encourage you when you see, well, this doesn't quite match, let me just make sure I did this correctly. Right, I pulled out the 2x squared, yeah, that's still x minus 2. I pulled out the negative 3, yeah, that's positive x plus 2. All right, I did it right. This one's just prime because I can't go any further. Right, remember, to do that last step, these two have to be exactly the same. If they're not, you cannot factor it. All right, so that's the factor by grouping method. Oh, one thing I should have mentioned on this one, at the very beginning, if we look for a common factor with the 2x to the third and the 4x squared and the 3x and minus 6, they don't all have a common factor, right? You can confirm that for yourselves, but that should be always the first thing you check. I neglected to do that this time because I already knew what the answer to the problem was going to be, so I kind of just jumped right into it. But when you're doing any type of factoring problem, you should always look for that common factor first. And then if you don't have that, identify, well, I have 4 terms here, so if I can factor this, it's going to have to be by the factor by grouping method, right? And sometimes that works like it did up here, and sometimes it doesn't.